Hi, this is PV Rajunit of 14BC0053 of B2 slot submitting a video lecture on hex keypad interfacing with 8051 microcontroller. Contents are introduction, working principle, components required, programming for Atmel 8051 microcontroller, applications, result and future implements. Introduction to the topic are ancient time keyboard was used to get proper input in the machine. Interfacing microcontroller with keyboard makes it faultless and make input rate faster. Whether the input is any numeric or any alphabet, microcontroller bakes those inputs into hex code, and with the help of lookup table and proper programming language, it helps to give a prompt input from the users. History. Christopher Latham Scholz invented the modern QWERTY keyboard in 1870s. Hermann Hollerith developed the first key punch devices. In 1930s, electric typewriters were invented. In 1936, August Dvorak patented a new layout to Dvorak keyboard. Personal computers keyboard in 1970s. Expert is a keyboard built in 2003 for speed, dash and dash, easy transition from QWERTY. About our work, matrix keypads are well known for the simple architecture. Here we are using 8051 microcontroller. We can use only a number of 7 segment display or LCD module where encoder and multiplexer is required. Designing of the construction of a hex keypad. Hex keypad 16 key from 0 to 9 and A to F. Matrix form is required to reduce the pin count in microcontroller. Here we show the this one circuit diagram of model circuit diagram of hex keypad. To detect a key, 2 approaches: 1 column scanning and 2 row scanning. We are using column scanning. Okay, make each row 1 and others 0. Okay, each row 1 and others 0, and then scan each one automatically. Okay, if any switch is pressed, corresponding column sense value is 0. The pressed switch make the corresponding column and row shorted. Okay, now scanning is just the opposite of the column scanning technique. Whole arrangement. This is the 8051 microcontroller, and this is the ports of 8051 microcontroller, and here is the hex keypad, and here is the LCD 7 segment display for this thing. As we all know, 8051 microcontroller contains 8-bit CPU, 4 KB of chip RAM, program memory, 128 bytes of on-chip data RAM, 4 ports of 8 bits each, 2 16-bit timers, full duplex serial port, on-chip clock oscillator. Okay. The 7 segment display, actually we got this in DLD also, like 7 segment display. This will we use this 7 segment display in calculators and even in mobile phones. Like 8 will be there na, on other 1 and 2 and 3 will, everything will come in that 8 only. And common cathode diodes required positive voltage, common anode diodes required negative voltage. Both works in forward bias. Programming should be done according to the diode we use in display. Other components we use are 17-piece tag switch, 8 330 ohm resistors, 1 8.2 kilo ohm resistor, 11.0592 crystal oscillator, 33 picofarad capacitor, 10 microfarad capacitor, 5 volt power supply. Here I am showing the program of this keyboard interfacing using 8051 microcontroller ORG00H. This is the common for every program, and this will be the program. This is the program for the 8051 microcontroller using this 8051 microcontroller code for the keyboard interfacing. These are the other problems we have faced using this code, and the voltage directly goes to the 7 segment display. The voltage in the 2 legs of crystal oscillator is totally different from the college kit. Soldering is not up to the mark according to that we burn the 7 segment display twice, giving 5 volt directly to it. Burned the program in different pin in the microcontroller. We tried lots of coding or program for hex keypad. Resultant future work. Basic calculator. Here we can use LCD module instead of 7-segment display. Here we can perform and display various operations like addition, subtraction, multiplication and division. Multiple display device. Here we can use multiple 7-segment display. It can be used to display 2-digit numbers. Okay. Projection keyboards. This brings us to a similar but significantly older idea of projection keyboards, which do exactly that: project a virtual keyboard onto a surface and track your finger movements and as you type depending on configuration. Projection keyboards typically use a combination of lasers, sensors and infrared beams to replicate a traditional QWERTY keyboard on a flat surface. This idea is to optimize portability by providing a full-size keyboard for mobile devices, which at the same time eliminating the pesky tradition of physical matter to visual keyboard. Thank you. I'm hereby ending my presentation. Thank you.